So we are going to learn how to recognize the shape of polynomial, graphing polynomial, so easy without building specific point. Okay, just the shape of it, looking at this polynomial, let's say in this case polynomial in the form of monomial, because we have one term only. So how we can imagine the shape of this polynomial? So first of all, we are looking at the degree. Degree is even. When degree is even, then both ends are going either up of this polynomial or they are going down. In the middle, we don't know how it's gonna go. We are exploring end behavior, the ending. So when a leading coefficient in this, this is a coefficient, if it's positive, so this is our A, this is our X. If our A, leading coefficient, is positive, greater than 0, then both ending at the ends are going up. If our leading coefficient and A is less than 0, then both ends are going down. Since I already started, then let me continue. What if a degree, let me see. This degree for, what if the degree is odd? Then when coefficient is positive, then the graph is increasing. See, it's growing from left to right, and well, in the middle we don't know how it looks like. Right now we're exploring only end behavior. If leading coefficient less than 0, then graph is decreasing. Okay, and in the middle, so we don't care how it looks like right now. All right, so in this case, so we have the degree is even right here, and the A is 7, so degree is equal 4, which is even, and A coefficient is equal 7, which is greater than 0. So it's going to be this case, right? All right, which means the graph is going to look like this. Both endings are going up. Next one. No, hold on, we have more questions here. Let's explore more. So where the function, let me write down A, point A. So on which interval the function is increasing. So the function is, this is on, comes here like this. So the function is increasing on this interval, yes? On this interval, function is increasing because numbers are growing from left to right, right? From negative to positive. So from 0 to infinity, x interval is always interval of x, so it's going to be from the 0 all the way to positive infinity, right? So it's going to be increasing on an interval 0, infinity, okay? And B, decreasing. It's decreasing on in this area, see, it's going down. So which is going to be from negative infinity, right, all the way till 0. This is turning point right here, from negative to positive. So it's gonna be from negative infinity to 0. Okay. Question number 2. Graphing polynomial f of x is equal positive 5/8. Let me do it negative so it would be more interesting, because we have tried already positive. Now let's do with negative. Negative 5/8 x to power 7. All right. So let me move down so we can use it. Okay, good enough. So negative 5/8 x to power 7. Let's see, our degree is 7, yes? Right here. So, which is odd. A, negative 5/8, which is coefficient A. So this is less than 0, right? Okay, so odd and less than 0. Here we have odd and less than 0. And this is going to be our form. Okay. So that means the graph is going to look like coming from here and then going down here. Something like that. Okay? That's a shape. Now, A, what we need to do? It's asking where is increasing. Let's see, where is it increasing? Let's start. Here is decreasing. Decreasing, continue, inflecting here, and then decreasing again. So it's not increasing anywhere, right? So we put no increase. No increasing. And B, it's decreasing throughout the entire the function, right? Which is from negative infinity at x all the way to positive infinity, correct? When we're talking about increasing, decreasing, don't get confused. We are not talking about y, we are talking about on x interval, from negative infinity to positive infinity. Next one. Let me move this down. Okay. So, question number 3. This time we have f of x is equal 2/3 of x, 2/3 of x cubed plus 2. All right, so let's see. Degree is free, right? Here it is, which is what? Odd. Next, coefficient of A is 2/3, right? which is greater than 0. Okay, add and greater than 0. It's gonna be this one, right? Add greater than 0. Okay, so the graph is gonna look like this. I forgot. See, we have here plus 2. Plus 2, that's a shifting on y-axis, which means the graph will look like this is 2. Considering this is 2, the graph is going to go like this. So up by these 2. Okay, there we go. Next, increase, decrease. So let's see where is it increasing. It's increasing from here to here, and it's continuing increasing from here to here, which means increase on interval negative infinity, positive infinity. B, decrease, doesn't exist, not applicable. Or I can put no decrease. Next. So next we need to sketch the graph of the polynomial. Question number 4. Sketch the graph of the polynomial f of x is equal negative x plus 3 cubed, x plus 3 cubed plus 3. Okay. So, first of all, okay, yeah, let me move this down. Like I said, without doing much of calculation, I'm going to show you how, looking at the polynomial, you can sketch the graph. So, first of all, the degree is 3. Here it is. This degree. This is what we mean. It's add. Coefficient A is this one. That is -1, yes? Because it's -1, so which is less than 0. So add and less than 0. This is going to be our shape, yes? Okay? So we know it's going to look like that. But see, here we have some new changes. Here we have change of x and change of y. We already know how it works. One thing we need to know. So let me graph here. So degree 3 and -1, the graph is going to look like this. So this will be negative x cubed only. Now we need x plus 3. So we need here x plus 3 cubed, which means x is going to shift, always x going to shift it towards opposite sign. Why? Because if I have x plus 3 cubed is equal 0, then x plus 3 also equals 0, and x is equal negative 3. So what do we see? While x we have here positive 3, we end up shifting by negative 3. It's always going to be like that. So you're always going to shift x towards opposite sign, okay? But not y. Y is going to be moving up and down the way it's given. Okay, so this graph, where is our x? Is negative 3, so we are moving to negative 3. Let's say 1, 2, 3. This is negative 3. And moving up by positive 3. 1, 2, 3. This is negative 3. This is positive 3. So what's happening? This 0 we had originally, moving to this point. So this graph, this one I'm talking about, this graph, it's gonna go through this point. Through this point. So it's gonna look like this. See, the shape is the same as we showed here. With the difference, instead of going through 0, it went through negative 3 here and positive 3 here. Okay? All right. So A, let's talk about increase. So do we have here increase? Absolutely not. We have decrease throughout. So there is no increase. And B, decrease. Obviously it's going to be from negative infinity to positive infinity throughout the entire x-axis. Next, question number 5. Here is asking the end, describe the end behavior, okay? We already know, right? End behavior here. Okay? F of x is equal 8x to power 5 plus 2x to power 3 minus 5x and plus 3. So what is going to be degree in this case? We have degree 3, we have degree 5. Here will be degree 1. Which one is degree? The highest degree. In this case, it's going to be 5. The highest degree, it's going to define the degree of the polynomial. So degree is 5, which is odd. And the coefficient of this degree 5 is 8, which is greater than 0. So what is going to be, which the end behavior that we have here, which the one will be the answer odd here and greater than 0 here. So the graph end behavior, it's going to look like this and this. Okay? Okay. Next, question number 6. Again, describe the end behavior. We have f of x is equal negative 2x cubed plus 4x squared minus 3. All right. Highest degree is 3, right? And coefficient a is negative 2 for that one. Okay? So which means the graph negative and degree is odd. Here we have degrees odd and A is negative. So the ending is behavior is going to be like this. Because it's this case, right? Okay. Question number 7. I have f of x is equal 7x to power 6 minus 2x to power 4 plus x squared minus 5. Okay, let me move this down. We keep using this. So what do we have? Highest degree, 6. And coefficient is 7. Right here. So what does that mean? So degree is even. And A is greater than 0. Okay. So A is greater than 0 and even, so we have this case, right? So, which means end behavior, it's gonna look like this. Number 8, another end behavior, we need to describe f of x is equal 5 plus 4x minus 3x squared minus 9x to 10. Okay, highest degree is 10 and coefficient is 9, negative 9. So here we have even, here we have less than 0. Even less than 0, this is going to be this one. So the answer is going to be down, down, both are down. Question number 9, we need to graph. Okay, now we need to graph. Here we are going to use already points. So before we did sketching and then end behavior, now we are going to draw the graph precisely. So it's going to be f of x is equal twice 2x, x minus 4, x plus 1. Okay, let's see. First of all, what do we have? Let's understand end behavior and let's understand degree. What is going to be the degree? Since we have multiplication, if I would open this parenthesis and I would multiply by each other, what degree I would get? Here I have degree 1. Here x also degree 1. Here also degree 1. 1 and 1. So this 1 times 1 will be 1. Also 1 times 1 will be 1. So here we have 1. Here we have 1 and here is 1. So we multiply at x times x times x. We are going to get x cubed, right? Because when we multiply, here is 2x times this x and then times this x. So these 3x multiply by each other, we are getting cube. What do I mean? What if we would have, let's say, 2 being here, or then it would be 1 plus this 2 and plus this 1 would be 4. Okay? If I would have, let's say, here is 2, here 3. Then will be, I had to multiply 2 times 3, because once I open it would be 6 here. So this would be then 1, this would be 6, and here would be 1 also. So 1 plus 6, 7, 7 plus 1 is 8. Okay, that's how we count total degree. Where did it jump? Okay, right here. So in this case we have here degree 1, here degree 1, here degree 1. So it's going to be 3. 1 plus 1 plus 1. Degree 3. Coefficient, it's going to be 2. Because this is going to be, if you multiply 2x times this x times this x, it's going to be 2x cubed, right? If I would have here, let's say 3x, then would be 6 coefficient. Okay, if would be some other coefficient here, then it would be times this coefficient also. But so far we have only coefficient 2, therefore our coefficient is 2. Okay, so which means our end behavior, we have degree 3, which is odd, and we have 2, coefficient 2, which is greater than 0. Odd greater than 0, it's going to increase, so this is going to be the end behavior. Now let's look the midpoints. So we know one end is coming like this, one end is coming like this. Let's figure out what's going to be in the middle. So what do I have? 2x times x minus 4 times x plus 1. If this is equal 0, because the point to find where it's crossing x is here, right? Then my y on x-axis is going to be 0. So I'm assigning it 0 to find out at what point of x it's crossing. So if I assign it equals 0, then it's going to be either 2x is equal 0, where x is equal 0, or either x minus 4 equals 0, where x is equal 4, or x plus 1 is equal 0, where x is equal negative 1. So these 3 points are our the x-intercept. So coordinates will be x is 0, y is 0. Here x is 4, y is 0. And x is negative 1, y is 0. Why did I put everywhere 0? Because here it's equal 0. This is f of x, which is the same y. So let's mark down. I'm going to clean this, draw one more time, because I had it with all points. Okay, it's gonna cross here 0. It's gonna cross, let's say this is your positive 4, 0, and negative 1 will be somewhere here. Yes? Okay, those are going to be our x-intercept. Now let's understand when we have this point, how it's gonna work. Is it gonna, this point cross this way, or this point cross this way, or it's gonna turn down, or through this point it's gonna turn up? We don't know, but I'm going to show you right now. So first of all, we always starting with exploring these points that are the closest to end behavior, which are this one, close to end behavior, and this one, close to end behavior. Yes? Okay. Now this one is negative 1. This one is positive 4. From where we got negative 1? Negative 1 we got from this one, which is here, x plus 1. So what degree has x plus 1? Degree 1. 4 we got from this one, which is here, and what degree we got here is degree 1. Now, when these degrees, right, these ones I'm talking about, exactly these ones, when these degrees are odd, okay, then these points we have, it's gonna cross either from left to right, or it's gonna cross from right to left. How are we gonna figure out? So this is when it's odd. These ones and ones we have, we call multiplicity. Let me rewrite it. Multiplicity. So how do we know which way it's going? Let's take this point, -1. We have it 1 right here, which is odd. So since my endpoint on this way, then obviously it's going to cross this way, right? So it will be connected to endpoint, right? And this at the point 4, which is also degree 1, which is odd. So it's going to go from left to right, from right to left. So the end behavior is on this side. Therefore, it's going to go cross this way. So we can connect to our end behavior. Yes? Okay. Well, it's obviously we are going to see how it's gonna cross 0, but let's analyze. So we have left 2x here. We have here left 2x with 0, 0, and degree is also 1, right? Which means also it's gonna cross left to right or right to left. And the position of these two open endings, it's dictating that it's gonna cross from here to here. Now, if it's gonna come this way, or come this way, come down, this way, come down, you can do it by taking, you can figure out by taking some point, let's say right here in the middle. Yes, plug this value. Let's say this will be negative 0.5. Yeah, and plug it here. X is equal negative 0.5 and calculate. But we don't need it. I'm just doing approximately this shape here, but more importantly, we are going through these points. And the same way, it's going to be this one. So I can take some points here. Let's say I can take here 1, because 1 is easy. If I take 1, let's see how much will be my y for point 1. So 2 times 1 times 1 minus 4 times 1 plus 1. How much will be? We get 2 times negative 3 times 2. 1 plus 1 is 2. So negative 6, negative 12. Wow. So which means this piece, we have to stretch down all the way to negative 12. Let's say this much piece is 4, so it's gonna go all right. I'm going to break proportion because it's gonna go too much down, so I'll put negative 12 here. So which means it's gonna come down here and come back here, and this is how it's gonna look like. Let me make it looks nice. And this one also. This is how it's gonna look like. Okay? Question number 10. So we need to graph f of x is equal x squared okay, x minus 3, x plus 2 squared. Okay. So, how it's gonna look like? We have, okay, let me draw the graph. How much is total the degree? We have here 2. We have here 2. And here we have 1, right? So degree is going to be 2 plus this 1 plus this 2. So it's going to be 5. Okay, it's odd. Yes? Degree is 5. Odd. Okay. Let me clean this, not to make it messy. And the coefficient, A, here is our coefficient, 1, and it's positive. Greater than 0. When we have odd and coefficient is positive, then our end behavior is growing right here and here. Okay, we know end behavior. Next, we need to find our intercept, y-intercept. So this time I'm not going to break down like this, but you already know what I'm going to do, which means when we have just x, that means it's going to be 0. X will be equal 0. If we have here x minus 3, so then x is going to be equal 3. Because x minus 3 is 0, then x is equal 3. Since we have here x plus 2, then x is going to be equal negative 2. Let me write down. X is equal 0, x is equal 3, and x is equal negative 2. How we get? Again, just like here, same way. 2x is 0 is 0, x minus 4 is 0, x is positive 4. See if it's negative 4 here, positive 4 here. Positive 1 here, negative 1 here. So, looking at this, we're going to do exactly the same way. So we have only x is 0, x minus 3, then x is positive 3, x plus 2, then x is negative 2. Which means here we have negative 2, here we have 0, here we have positive 3. Okay, now we need to understand the behavior around these points. So, all right, let's do it. Again, remember what I said. We need to start with points that are close to end behavior. So we will go explore point negative 2, positive 3, and only then 0. All right. So what do we have? At the point of x, the negative 2, which one gives our negative 2? This one. This one gives us negative 2, right? In our degree is 2, correct? Degree is 2. So we learned when around the point, if degree is odd, it's crossing from right to left or from left to right. But when it's even, it's either gonna turn point up or turn down. Now we have at the point negative 2, we have it even, right? 2, which means since our end behavior is down, that means it's gonna turn down point. There we go. Next, at around point 3, which is this one, x minus 3. So end behavior is 1. I mean, this multiplicity degree is 1. Since it's 1, it's odd, which means it's going to cross from left to right or from right to left. So since our end behavior on this side, it's right here, then it's going to cross this way. Yes? Which means at the end behavior, at the point of 0, so it's either can go like this, okay, or come like this. How do we know which way? We are looking at point x is equal 0, which is this point, right? Right here. We have degree 2. Degree 2 meaning turning either up or turning down. Yes? All right. So since our both ends are down, which means this 0 is turning down. Correct? And to know this connection goes like this or goes like this, all you're going to do, take some point, let's say -1. And we can figure it out. And we take +1. We can figure out how it crosses. Let's take -1. Let's take here -1. So it will be -1 squared, -1 minus 3 to power 1. We don't need to write it. And -1 plus 2 to power 2. This is our f of -1. We put the value of -1. Okay, so f of -1, it's going to be equal. -1 squared is 1. -1, -3, it's going to be -4. And -1 plus 2, it's going to be +1. And squared will be still 1, which is going to be equal -4. So, okay, since our, let me see. This is our 3, this is going to be our 4. So it's going to come, did I calculate? Me double check. -1, so it's going to be 1. This is -1, -3. It's going to be -4. And -1 plus 2 is 1. Okay, why is going to be -4 when x is 0? So it's going to be something like that. And if I take +1, so if I take +1, it's going to be 1 squared, which will be 1, +1 minus 3, and then +1 plus 2 squared. We are getting 1 times -2 times 3 squared 9, so -18. So it's going to drop drastically down somewhere -18, which means if this is -18, hold on. Then this one I should make a little bit smaller so it would proportion at least keep. Okay, so this is how the graph it's gonna look like. Okay? All right. Moving to question number 11. So we have g of x is equal x minus 2 to power 2 and x plus 5. All right. For the graph, how much we have degree? Our degree is will be here 2, here will be 1, right? Degree 1. So we have 3. Degree 3 is odd, and our coefficient is 1 and positive, yes? So let's write down. Degree is equal 3. Coefficient A is 1. So this is odd, and this is greater than 0, which means end behavior is going to be like this. All right, let's look in the middle. We have x minus 2 squared, and we have x plus 5. So x minus 2 squared, so equals 0. That means x is equal 2. X plus 5 is equal 0. X is equal -5. Our 2 points, it's going to be +2, let's say, and this is -5, approximately I put there. negative 5. Okay, let's explore point behavior around. So positive 2, our degree here is 2, which is even, which is going to turn either up or turn down, right? Looking here, so since our end behavior on this side, that means it has to turn up. So we can connect with this one. Negative 5 degree is 1, which means we have to cross at the point negative 5. And it's going to cross, let me see. It's going to cross this way because end behavior is on this side, right? Okay, now, so obviously it's gonna be either crossing like this, right? Or it either cross like this. So which way it will go, we have to pick up some point and explore. Okay, so I suggest to see where it's crossing, which means take x is equal 0 and find y-intercept. Okay, when we take x is equal 0, what we have? G of 0, it's going to be equal 0 minus 2 squared and 0 plus 5. So G from 0 is equal negative 2 squared times 5. Negative 2 squared, 4 times 5, it's going to be 20. So, wow. So it's going to go to up to height 20. Let's say this is our 20. It's going to come here and come back right there. Okay? And this is how the graph will look like. Okay? Question number 12. Going to graph f of x is equal x cubed, plus 3x squared minus x minus 3. Okay, for this one, we know that degree clearly is 3. And the coefficient a is going to be 1. Okay. So free and positive, so end behavior, it goes like this and go up like this. So now let's find out these points on the axis, how we can find out through here. So I have to do some, I have to factor it down. Bring this format, bring to this format. Okay, so we can work with it. Let's see. X cubed plus 3x squared minus x minus 3. When we have 4 terms, it's for factoring, we usually use grouping. Okay, we use grouping. So it's gonna be x cubed plus 3x squared minus x. When we put in parentheses and we have negative here, see this negative, then we're gonna change the sign in parentheses. Negative x, it was negative x, here became positive x. It was negative 3, became positive 3, okay? All right, next, taking common factor out between these parentheses, we have common factor, it's going to be x squared. So inside will be x plus 3. Because when I take x squared out, I do 3 minus 2, this 3 minus this 2, and then I do this 2 minus this 2. Which will be 0, and to power 0, I get 1. Okay. Whoever wondering why I got x plus 3, open in my intermediate math or basic math, or search in there. Search for common factor and you will see how I work there. Or I can put at the end of this video common factor. All right, x plus 3 minus, and here we have x plus 3. Okay, let's see. This is one term. This is another term. Both of them have x plus 3. Yes? So I'm going to take this x plus 3 out. It's a common factor. So from the first one, I will have left only x squared. From the second one, I will have left only 1. Minus, because here I have minus. Okay, I brought to the level already. So what does that mean? Let me move this graph down. Okay, so I have x plus 3 equals 0, so my x is equal negative 3. And I have x squared minus 1, 0, which means x is equal positive 1, and x is equal plus minus 1. We have 3 points. Negative 3 plus minus 1. So, negative 1, positive 1. Actually, I could make a little bit wider these points. Let's do this way. Negative 1, positive 1. Go like that. And negative 3. Okay, this will be negative 3. Negative 3. Negative 1. This is positive 1. Okay, let's explore. So at the point negative 3 and positive 1 first. So negative 3, when I'm looking at negative x plus 3, degree is 1, which means it's gonna cross. And it's gonna cross this way because in behavior it comes this way. Let me make it nicer. Okay, now positive 1, because positive 1 is close to this end behavior. So positive 1, negative 1, here we have degree, how much? 2, right? Which means it's going to be turning point. And it's going to turn no, it's not going to be turning point because I have x squared, it's for 2 ones, one positive 1 and negative 1. Okay. Don't let me fix it. Okay. So it's going to be degree 1 instead of 2 because here we have degree 1. So which means what we're going to get? This is also going to be the crossing, and it's going to cross. Let me do it here. It's going to cross like this. Yes? Because in behavior on this side. And negative 1 also it's going to cross, which means it's going to cross like that. So if you are interested to see these midpoints, where it's going, take this point, take here point, and calculate precisely how much it's going to be. But the easiest way would be, I can tell you right now that this point, it's going to cross something. It's going to go, hold on. If this is this gonna go through negative 3, something like this. Why? Because when at this point x is 0. If I plug throughout this x is 0, like right here, because this is our original one, right? If I plug it to x equals 0, we will end up with negative 3. Therefore, looking at that, I can say that this point is going to be -3. Okay? All right. We are done. Moving to question number 13. So, f of x is equal x cubed minus 10x squared minus 375x. Okay, so we have x here, x here, x here, which means right away I have to take x out and get x squared minus 10x minus 375. Okay, well, what do we have? The looking at this degree, highest degree is going to be a degree 3, correct? And the coefficient a is equal 1, because here we have 1. Okay, so, and behavior, it's going to be like this and this. So what are going to be our points? So x is equal 0. This is this x, right? I can put x is equal 0. So one point is going to be right here. And the other one, x squared minus 10x minus 375. This is going to be calculated as a quadratic expression. Now, if we break it down, it's going to be big numbers. So therefore, I can use in this case, let me see how to explain. Since this point of 0, let's think this way. So we are going to just draw the shape, not precise values, because this is too big of a number to go through all this. Which means what we are going to do, since x is here, we know 0, and it has degree 1, right? So that means it's going to go like this, or it's going to go like this, correct? Okay. Since we have here x squared, that means we're going to have another 2x's, correct? Either here or here somewhere. Another 2x's. So to avoid going through all this calculation, see how I'm thinking. So if it goes like this, so that's mean it's gonna cross this one. No, I guess we have to solve it. Okay, let me one second. Let me calculate. Give me 1 second. I will do it and let you know right away. So let me write down x to power squared minus 10x and minus 375. Well, I have to go through long calculation. Okay, this one is going to be long calculation, x squared minus 10x minus 375. Okay, and I'm trying to figure out if should I go through all this or just give you approximate values. Now this one is going to be x minus 25 and x plus 15. Why is that? Because remember when we, let me see, yeah, we can factor it easy way also. This negative 25, when I multiply by 15, I'm going to get negative 375. And if I take negative 25 plus 15, it's going to be negative 10. It's right here. Now, you don't have to go through all this, but one thing you have to know. So, it's going to be one, since we have endpoints here, an endpoint here, which means, and we know we are going to have 2 points, right? One here, one here. Yes? Now, more importantly, to know if it's going to cross like this, or it's going to cross like this. So we know that since this is quadratic equation, quadratic expression, it's going to have degree 1 once after you factor, right? Once you factor, it's going to be degree 1, it's going to be degree 1, right? That's what's important for us right now, which means degree 1, which means it's going to cross it and not turn. So if it's going to cross it, then it's going to go obviously like this. And if it's going to cross it here at the second point, it's going to cross like this also, because then behavior is like that, which means around this 0, since we decided what around point of 0, it's going to cross also. That means it's going to go, the graph is going to go like this, cross this way, right? Because we know it's going to cross. Right here we have degree 1, remember? Okay. And the graph is going to look like this. Now, you don't have, in your case, you do not have to break into specific numbers unless you know how to do it. If you don't, I'm going to put at the end of the screen factoring and common factor, okay? So you can go and look. Now, to know approximately just point, 1 point, 2 point, more importantly, you need to know this multiplicity, this degree 1 and this degree 1. So you will know that it's not a turning point, but it's going to be crossing point. That's all you need to know. That's the most important part, just for sketching the graph. And that will be your answer. Okay, moving to question number 14. So for question number 14, f of x is equal to x cubed, x squared minus 1, and x minus 2. Okay, let's go a little bit faster since already we have so much experience of doing already. So what do we have here? In this case, here we have degree 3, here we have degree 2, and here we have degree 1. So 3 plus 2 is 5 plus 1 is 6. Okay, if we have 6, degree is equal 6, that means both endings are going up, right? No, we don't know, up or down, both of them. Okay, coefficient is 2, here it is, positive, which means both endings are going up. And our point, 2x cubed, which means x is going to be equal 0. Let me write down 2x cubed equals 0, which means x is equal 0. X squared minus 1 equals 0. That means x is going to be equal plus minus 1. And x minus 2 equals 0. X is equal positive 2. So we have 1 2, 3, and 4. 4 points. 0, -1, +1, and +2. Okay, let's see. Starting from with -1 and +2 points that are close to end behavior. -1, since we have x squared for 2 answers, so we have degree here, our multiplicity is 1, right? Is 1, which means negative, at the point -1, it's gonna cross. So since end behavior is going like this, so it's gonna cross this way. 2, also multiplicity is 1, so it's also gonna cross, and it's gonna cross this way. Now let's look at the point 1 and 0. +1, so for +1 is multiplicity is 1, yes? Therefore, since the other end is hanging at the bottom, right? That means this 1 has to cross like this, so it can be connected, correct? And it's obviously it's already seen, it's gonna cross also. And for 0, we have degree 3. 2x is cubed. It's equal, the degree is 3, which is odd, right? Which is odd, which means also gonna cross. And it's gonna cross right this way because it's 1 is on the top, 1 is at the bottom, see? And this is how the graph is gonna look like. Question number 15. Okay, so what do we have? We have f of x is equal 4x squared minus 2x minus 3. So we need to find if there is real 0 between numbers 1 and 2. What does that mean? Let's say, okay, I'll explain as I solve. So first thing, this 1 and 2, those are values of x. So therefore, let's find out what's the value of y or f of x in the point of 1. So f of 1 is equal 4 times 1 squared minus 2 times 1 minus 3. So f of 1 is equal 4 minus 2 minus 3. It's equal -1. Okay? So when x is equal 1, f of 1 is equal -1. So that's a coordinate practically, 1 and -1. There we go. That's the first one. Second, point 2, f of 2, this point. So f of 2 is equal 4 times 2 squared minus 2 times 2 minus 3. So f of 2 is equal 4 times 4 minus 4 minus 3. So which is equal, let's see, 4 times 4 is 16. 16 minus 4 is 12. 12 minus 3 is 9. So it's equal 9, which means when x is equal to f of 2 is equal 9. So the coordinate is going to be 2 and 9, right? Okay. So let's understand here one thing. If I'm drawing here graph, real quick. So let me mark down this one also. Positive 1 and negative 1. Let's say positive 1 and negative 1. This is 1 point. Second point, positive 2 and positive 9. Let's say this is 9. This is another point, yes? So what do we get? 1 point here, 1 point here. So if I connect them, it's going to cross here, right? X value, correct? Which means there is a value of 0 here, right? Of y is equal 0 at this point, correct? Right? So therefore, we can say that there is a real 0, there is value of 0 between these 2 points. This is 1 and negative 1 point, and this is 2 and 9. So between these 2 points, there is a value of real 0. Here it is 0 value. Algebraically, this is on the graph. Okay, we know. Algebraically, we can say that f of 2, which is 9, is greater than f of 1. Yes? So, since f of 2, because f of 2 is 9, f of 1 is negative 1. So, since f of 2 is greater than f of 1, then the function is increasing, right? It's going from lower point here. It's moving to higher point here. Yes? Moving to higher point, increasing. And so there must be one real 0 between 1 and 2. The bottom line is, let me tell you something. I'll show you a shortcut. So, negative 1, f of 1 is negative 1. This is negative. This is y equal negative. This is y equal positive. So to move from negative y, from anywhere from negative y to positive y, you're going to cross this value of x0, right? Be it from here, be it from here to here, either way. You are going to cross value of x in the point of y is equal 0. So if signs of these y's, like f of 1 and f of 2, flipping the sign, positive become negative, negative here, positive here, they have different sign. That means there is definitely, we have real 0. Okay? I'm trying to clean this part. Let me see. There we go. Question number 16. Same thing. Question number 16. So f of x is equal x cubed plus 4x squared minus 8x minus 10. Okay, this is we call intermediate value theorem. Here also in this problem 15, we also used intermediate value theorem. So using intermediate value theorem, show that function has a 0 between point A and B, where A is equal negative 6, B is equal negative 5. So practically it's not questioning, the task is not questioning, it's telling us to prove it. because they mention that so that it does have 0, but we need to prove it. So what did we learn from the previous question? If I plug a is equal as an x, I will plug as negative 6, and I will plug into f of x, if b is negative 5, I will plug as an x. And the value of y I get, it has to have opposite signs. Because if you have opposite signs of y's, that's mean if I connect them, so there is going to be real 0 between them, because they're going to cross x to connect to each other, right? So let's do it. So f of negative 6 is equal negative 6 cubed plus 4 times negative 6 squared minus 8 times negative 6 minus 10. Okay. So that is equal f of negative 6 is equal negative 6 cubed. So negative 6 is going to be squared, going to be 36, and then 36 times another 6 is going to be 36. And 6 times 3 is 18, and 3, 21 will be negative 216. Why negative? Because when we have base is the same, negative, and if our exponent is positive, odd, which we have odd, then the result is going to be negative. Why? Negative 6 times negative 6 times negative 6. Negative, negative, positive, and then this positive with this negative is going to be negative. For that reason. Therefore, one more time, if our base is negative, then if the degree exponent is odd, then result is negative. If exponent is even, then result is positive. Okay, negative 216 plus negative 6 squared is going to be 36. So 36 times 4, it's going to be 24, and 244 positive, because negative 6 squared is going to be positive 36. And then here will be plus negative 8 times negative 6, it's going to be positive 48. So what do we get? So I'm at negative 216. So 216, I'm going to subtract 144 because it's negative positive. It's going to be negative, right? The result going to be negative because 216 is greater than 144. All right, let's see. So 6 minus 4 is 2, 11 minus 4 is 7, and that's it, 72. So we get negative 72. If I put plus 48, again, I have to subtract. It's going to be negative 72 plus 48. Result is going to be negative, and we need to subtract 72 minus 48. 12 minus 8 is 4. 6 minus 4 is... Okay, I think somewhere I have mistake. It should be more than, let me see, let's double check it. So negative 6, meaning 6 times 6 times 6, 216, correct. So next, 4 times negative 6 squared is 36. It's going to be 100. This is also 100, a negative sign. Okay. Here also we have negative because, no, it's positive. I was right. Negative 6 squared is going to be positive. So plus 144. And then, I left out negative 10. I didn't count negative 10. There we go. Found it. So it's going to be negative 72 plus 48 plus 10, which means 72 minus 48, it's going to be negative 24, right? and plus 10. Oh, it's negative, not positive, sorry. Guess I'm tired. Minus 10, minus 10. And we get negative 34. I was sensing something is wrong. Okay. We were getting too low, kind of. Okay, negative 34. Okay, so when a is equal 6, f of a is equal negative 34, which means the value for b equal negative 5, we have to get positive. Because if f of 6 is negative, then f of negative 5 has to be positive. Let's see. F of negative 5 is equal. So negative 5 cubed plus 4 times negative 5 squared minus 8 times negative 5 minus 10. Okay. Negative 5 cubed is going to be negative 125. So 4 times negative 5 squared here, negative 5 squared is positive 25. 25 times 4 is 100. So it's going to be plus 100. And then negative 8 times negative 5 is plus 40 and minus 10. So, and we are going to get negative 125 plus 100. It's going to be negative 25, right? And then plus 40 minus 10. Okay. I could combine these two also. 40 minus 10, positive 40 minus 10, it's going to be positive 30, right? So negative 25 plus 30, it's going to be equal 5. See, it's positive. That means, yes, we do prove that there is a real zero. So when b is equal 6, b is equal 5, negative 5, f of negative 5 is equal positive 5, which what does that mean? Here we got negative 34, here we got positive 5, which means there is real zero. Okay? So other way we say, since f of negative 5 is, which is 5, is greater than negative 34, then we have a real zero between negative 6 and 5 points. Okay. $17. X to 4 minus 3 x cubed minus 15x squared plus 24x plus 57. So we need to find, using intermediate value theorem, show that polynomial function has a real zero between given number negative 2 and negative 1. Again, it's not questioning us, and says show that it's there, which means we already know it's there. We just have to prove. To prove it, once we plug a value of negative 2 and negative 1, we have to get y, value of f of x, or value of y, which is same thing, with opposite signs. Because to move point from negative y to positive y, you are going to cross x is equal the value of x where y is equal 0, right? One more time, let me show you one more time. So having point, let's say here, remember I said one y has to be positive, one y has to be negative. And another point here, or anywhere here, doesn't matter. Once you connect, you are going to cross this point, which is a real 0, which means y is equal 0 at this point, right? Okay, that's what we are going to prove. That's for our goal, to show that if I plug f of -2 and then plug f of -1, I will get one positive, one negative. Let's go ahead. F of -2 is equal -2 to power 4 minus 3 times -2 to power 3 minus 15 times -2 squared plus 24 times -2 and then plus 57. Okay, -2 to power 4, it's going to be positive because 4 is even degree and we have base negative, which is -2. It's going to be, 16, 2 to power 4. It's going to be positive 16. Next, minus -2 to power 3. It's going to be -8, right? -8 times -3, by this -3. It's going to be positive 24. Next, -2 squared is positive 4, and then positive 4 times -15, it's going to be -60. Next, 24 times -2, it's going to be -48 and plus 57. Okay. So look, I'm going to go easy way, add all these positive numbers and then add both negative numbers and then either add or subtract based on result. And obviously we will subtract. One is positive, one is negative. So let's go. 16 plus 24 plus 57. I'm combining all positive ones. 6 plus 4 is 10. 10 plus 7, 17. 1 in mind. 1 plus 2 is 3. 3 plus 5 is 8. And this 1 will be 9. So we get 97. Next. We have -60 and -48. So it's going to be -108. Okay, 0 plus 8 is 8. And 6 plus 4 is 10. -108. So it's going to be -108. So since we have positive, negative, we are going to subtract, yes? And sign is going to be definitely negative because 108 is greater than 97. 108 minus 97. 8 minus 7 is 1. 10 minus 9 is 1. -11. Okay? So, next we need to get, this is important number we are going to keep in mind. Next we are going to do f of -1. So -1 to power 4 minus 3 times -1 to power 3 minus 15 -1 to power 2 plus 24 times -1 and plus 57. So we get -1 to power 4 is -1 because 4 is a even one. Oh, I said and put negative. It's gonna be +1. I'm definitely tired. Okay, next. -3 times -1 cube. -1 cube is -1 and times -3 is gonna be +3. Next. We are going to work on -15 times -1 squared. So -1 squared is +1 times -15 is going to be 15. Okay, next. 24 times negative 1 is going to be negative 24, and then plus 57. Okay, so what do we get? 1 and 3 and 57. So 1 plus 3 is 4, 4 plus 57, it's going to be 61. And then minus, so negative 15, negative 24. So both of them are negative, I'm adding, but the sign is going to be negative. 5 plus 4 is 9, 1 plus 2 is 39, minus 39. So 61 minus 39, 11 minus 9 is 2. Here will be left 5, 5 minus 3 is 2. So it's going to be positive because 61 is positive, bigger number, 22. All right, so what did we get? F of negative 2 is negative 11, and f of negative 1 is positive 22, which means we prove that there is 0 between negative 2 and negative 1. Okay? Question number 18. So we are given, here we are given graph, and based on graph, we are going to figure out what polynomial it is. This is 1, this is 2, so we are given point negative 6. Here we are given 0, 30. So its graph is coming like this. And it goes to negative 6. This is, let's say, negative 2. And this is positive 5. So it's coming down like this. Okay. All right. So first of all, we are going to identify x1 is negative 6, x2 is negative 2, x3 is positive 5. Remember when we were trying to solve our value of x's, then we had to, let me move it, move up so we can learn. Here, remember when we had x minus 2, right? We would get x minus 2, and x would have 2. Remember, if it's negative 2, then it's positive 2. The answer would be. Now we're going to go backwards, which means if x1 is negative 6, then 1 my x is going to be x plus 6. x2 is negative 2, then I will have x plus 2. x3 is positive 5, then it's going to be x minus 5. Okay? So now the other thing is also we need to find our coefficient. Yes. So to find our coefficient, I am taking this point when x is equal 0, y is equal 30. So I'm plugging here. I'll write down here, this is some coefficient a, we don't know, right? And this is our f of x. Okay, so we have here 0, 30, which means we can plug our x as a 0, and we're supposed to get 30. And from there we can find out our a. Let's do it. So 30, f of 0 is 30 equal a times, okay, it's gonna be 0 plus 6, 0 plus 2, 0 minus 5. All right, so 30 is equal a times how much? 6, 2, and negative 5. So result is going to be 6 times 2 is 12, right? 12 times negative 5, it's going to be negative 60. So 30 is equal negative 60a. Which means to find a, what we're going to do? Divide by negative 60 here, divide by negative 60 here. So this 60 and this negative 60 is gone, but here will be left, this is 1, here will be left 2. So a will be equal negative 1/2, which means our full format of polynomial is going to be 1/2 x plus 6, x plus 2, x minus 5. And this is going to be our answer. Okay, and the last one, question number 19. So we have graph. So it's coming from negative 5. And then here is 0, 9. Dropping to 3. And turn around up. So it's going to go like this. This is our graph. So x1 is negative 5. x2 is equal positive 3, and we have this intercept 0, 9. So what do we have? A minus 5, we get x plus 5, and then we have 3, we get x minus 3, but keep in mind, so we have here crossing, which is going to be odd, which is 1. But here we are turning around, which means it has to be, remember, it has to turn around. The multiplicity has to be even number, right? Which is going to be 2 here. Correct? Okay. Now what we have left to figure out our a, coefficient of a. For that, what I'm going to use is 0, 9. Let's see, 9 is equal, 9 is equal a times 0 plus 5, 0 minus 3 squared. So 9 is equal a times what we are getting, 5, and then times negative 3 squared is 9. Okay. So 9 is equal 45, 45a. So we divide by 45 because we need a. Here also divide by 45. This 45 is gone. 9 and 45, 1 and 5. So a is equal 1/5. A is equal 1/5. So, which means our polynomial looks like 1/5 x plus 5 x minus 3 squared. Okay, that's all. Thank you for watching. Sorry for mistakes, I wasn't attentive. Bye.